grade 8. How are you today, Miss? Today, inshallah, we will take lesson 2 from this chapter, which is actually multiplying and factoring polynomials. Now, actually, at the end of this lesson, you will be able to multiply a monomial by a polynomial and to factor a monomial from a polynomial. Miss, I want you first to understand the meaning of factoring. Now, if we say that, multiplying is going to the right, factoring actually is going to the left. It's just like dividing, it's just like division, but it's dividing polynomials. And it means that when you factor monomial, when you factor polynomials, it means you just split it or divide it into its basic parts. Okay? Now, I'm sure you will understand it more when we go to the meaning of factoring, because actually factoring is the same as finding the greatest common factor, finding GCF. Okay? Now, but let's talk first about multiplying monomial and trinomial. Now, if I ask you to multiply, it's the same process of using the distributive property. When you multiply a monomial by a binomial or by a trinomial, by any polynomial, you just use the distributive property and multiply a monomial by each term inside the parentheses. So, for example, if I ask you to find the simpler form of 5n multiplying by, Miss, let's take an example. If I want to multiply, as you can see here, 5n times 3n to the power 3 minus n to the power 2 plus 8. Now, in multiplying monomial by a polynomial, we will go back to the rules that we took it in adding and in multiplying and dividing and adding and subtracting exponents. Okay, when I have the same base. As you can notice here that multiplying monomial by polynomial is actually by using the distributive property. So, you will multiply 5n by each term inside the parentheses and then get rid of the parentheses. So it will be 5, we will multiply constants or coefficients by the coefficients, 5 times 3 is 15, and n to the power 1 times n to the power 3. If you remember, we say when we have the same base, we add the exponents together, so it will be n to the power 4, minus 5 times 1, 5, and here it will be n to the power 3, plus 5 times 4, 8, it will be 40 and n to the power, yes, it has actually, I have here n to the power 1 and I have here no n, so it will be n to the power, so I will keep it 40 n to the 40 n. So this is the answer actually. I multiply, I get rid of the parentheses by using distributive property. Now, if I ask you to find the greatest common factor, to find the greatest common factor, you need to factor or to make the factorization for each term and for each monomial in this polynomial. So, for example, if we take again this example, okay, I'm solving actually, got it 2. Here, if I want to find GCF, we took it as the greatest common factor. If I want to find it, I have to factorize, or I have to factor each term in this polynomial. So 3x to the power 4 easily will be 3. I have to find the prime factors. So times x times x times x times x. Now, 9x to the power 2 will be actually 3 times x times x. Now, 12x will be equal to 3 times 2 times 2 times, it's 12x times x. Then, what should I do, Miss? As we took in earlier I'm sure you took it in grades 5 and 4 and 6, okay? How to find it actually? We will look for the common factor, then we will multiply all of the common factors. I have here number 3, it's common, and although I have it here, but I don't have 3 here, I have x, it's a common between the 3, you know. So, and here I have only one x common, so what should I do? I will multiply 3 times x. So, as you can see here, miss, the greatest common factor will equal to 3x. Okay? We will do the same here to find the greatest common factor for each polynomial. Why do we need the greatest common factor? We actually need it to factor, okay? To factor it, which we will take it in the other lesson. Okay? So, Miss, have a nice day, and inshallah tomorrow we will speak about how to factor, polynomial or, binomial.